Hello everyone. In this video, we'll talk about z-values, how to compute them, and how to work with them. All right. This is all about standardizing the value in the situation where you're in a standard normal distribution. Um, so uh, let's just give the definition. In a normal distribution, uh, with mean mu and standard deviation sigma, as always. Sigma, a data point uh, x has z value z equaling, you subtract uh, the mean from x and you divide by the standard deviation. So um, let me sketch the graph just to get an idea of what we're talking about here. So this is kind of a poor sketch of the standard normal curve. I'm going to draw the axis of symmetry here, and we'll say that this is the mean. And you'll recall that there are these points of inflection that's sort of giving you the distance, and this should be symmetric about the symmetry, so I'm sorry for my drawing. And then within this distance here, that's going to be the standard deviation. So what does the z-value tell you? It tells you how many standard deviations you are from the mean. So if I give myself some data point here, then I can go up and I can say, well, this is the data point x. Sorry, I'll make it green. It's my data point x. But when I look at how far it is, it's 1 and say 2/3. So this distance here is 1 and 2/3, or 1 and 2/3, which is, 5/3, times the standard deviation away from the mean, which would mean that the z-value is of x is 5/3. It's saying what's the multiple of the standard deviation that you are away from the mean. That's what the z-value is telling you. And this is just the formula here for it. Okay, so the z-value gives you a good sense. And remember, we have these rules, this 68, 95, 99.7 rule. So um, if we're right at the 60 or this at um, the 83rd percentile, sorry, 84th percentile, then uh, we should have a z-value of around 1. Um, all right, so let's give ourselves a couple of problems and then see if we can understand. Um, so exercise 1, um, suppose a standard normal curve or distribution has mean 35 and uh, standard deviation of 6. Um, calculate the z-value for x equaling 42, let's say 47, and we'll say x1 and x2 equaling, um, let's say 21. All right. So all we have to do is apply this formula up here, and this is a good formula maybe to keep in your notes for an exam, um, or for a note card for an exam. Um, so let's go ahead and calculate it. So the first z value, so solution, the z value for x1 is, well, we take 47, we subtract mu, which is 35, and we divide by 6. So that's equal to 12 over 6, which is equal to 2. So this is telling, now what is this telling us? This is telling us that 47 is 2 standard deviations away, no, not just away, but beyond um, the mean. The z value for x2 is, again, we just use the formula. We're going to put x2 in for x. Let me bring this formula down so it's visible. We take 21 minus 35, divide by 6. So that's negative 14 over 6, which is minus 2 and 1/3. So that means that this is also, well, it's a little bit more than 2 standard deviations away from the mean, but it's to the left of the mean or less than the mean. So this is what this is telling us. So it's very possible to get the z value just by using that formula. But you can kind of reverse this type of a problem and have a different kind of a problem. So let's do this. So suppose a standard normal distribution has, we'll say mu equaling 4 and sigma, the standard deviation, equaling 3. A data point x has z value 3.5. What is x? Okay, so if you're in this kind of a situation, you again go ahead and use that formula that was written above. So I'm going to bring this down. I'll copy this formula. Bring it here. And let's take a look. So whenever you're in a situation like this, you want to kind of just fill in all of the things you know, and then see if you can solve for what you don't know. So what we are given is we're given mu, we're given sigma, and we're given the z value as well. So that means that we have mu, sigma, and the z value. And what we don't know is x. So we're completely unaware of that. But let's just fill in everything we do know. The z value is 3.5. We don't know x, so let's just leave it as x. We do know mu, so we put in mu. And we do know sigma, so we put in sigma. Now we're in sort of an algebraic equation situation. I know that's not fun for many, but this one's not too bad. So we can go ahead and we want to get like terms on on both sides. So we want to get a number on one side and our unknown on the other. So we'll go ahead, multiply both sides by 3, and we get 3 times 3.5 on the left equals x minus 4. So I just multiplied each side of the equations by 3, canceled the 3 on the right-hand side. Um, Multiplying out, I get 10.5 on the left. I still have x minus 4 on the right. Again, I still want to get like terms. I have a number over here, number here. I'm going to add 4 to both sides to get rid of that number. And I get 14.5 equals x. So it's, the equation is not going to be super complex, but it might help to go through a couple of them, just putting in some numbers into this equation to calculate maybe for the unknown. It's something to practice a little bit. Okay.